Algebra 2 students do the homework help video, pages 75 and 82. Let's go ahead and jump right into this and help you. Problem number 39 reads as follows. At 10 a.m. you are 150 miles from home. At 4 p.m. you are 390 miles from home. Find your average speed. Now, understand something. Average speed would mean miles per hour. In other words, how many miles did you drive in a certain amount of hours? So this should not be too difficult to find. First of all, at 10 a.m. you left. At 4 p.m. At 10 a.m. you are 150 miles from your home, okay? I should write that down over here. 10 a.m. you're 150 miles away from your home, alright? Let me erase this right here and get a little picture of this. That's always the best way to do it. Here's your home right here, and you're 150 miles. Here's where you start. You're 150 miles from home. Got it? Now, at 4 p.m., we're going to call this 10 a.m. Okay? At 4 p.m., now watch this, please. You're 390 miles from home, so that means your total distance from right here to right here is 390 miles. Okay? It doesn't mean you've traveled 390 miles. I want to make sure you see that. So when you started right here, you were 150 miles from your home. When you're here, you're 390 miles from your home. So my question is, this green line right here, how far have you traveled on this green distance right here? Well, if the whole distance is 390 and this much is 150, subtract the 2 and you will get 240. Okay? So from 10 a.m. to 4 p.m. you've traveled 240 miles. Now, how many hours did it take you? Well, from 10 a.m. to 4 p.m., think about it. You go from 10 to 11 is an hour, then to 12, then 1, 2, 3, 4, 6 hours. Okay? So 240 miles in 6 hours. That's going to reduce to, or take 240 and divide it by 6, and you're going to get 40 miles per hour. There we go. Back it up and watch it again if you need to, okay? Not too difficult. Number 40. On the day after payday, you have $200. We're probably going to need to know that, so I'm going to write that down. I'm going to put day after you have $200, okay? 8 days after payday, you have this much money. The question is, what is your average rate of spending, or at what average rate are you spending? In other words, how much money are you spending per day? Got it? How much money per day? Well, guys, this is not too difficult. I mean, this is the amount 1 day after payday. This is the amount 8 days after payday. So the total time from when you had 200 to 46 is 7 days. This is 1 day after payday, 8 days after payday, subtract the 2. That's 7 days. Now, how much money did you spend in 7 days? Well, you had 200, and now you have 46. So subtract the 2, and you're going to get 154. Alright? 154. So, you spent $154 in 7 days. Type into your calculator 154 divided by 7, and you're going to get always say with word problems, I always say relax and think. And number two, don't ask yourself, would I have thought to have done that? But say to yourself, do I understand what he's doing? And little by little, as you practice these, you'll get better at these. Now, we have the Leaning Tower of Pisa in Italy. It's 180 feet tall. Now here's the ground. We know one corner, one side is sunk 1 foot into the ground. So the Leaning Tower the tower used to be like this when it was first made, and now it's sunk into the ground. So I'm going to draw the tower. Here's the ground right here. I'm going to draw the tower like this. Here's the base coming up like this, and the building, of course, is slanted. Now, mine's not drawn to scale very well. That's not a big deal. There. Now, what do they want us to do? Read the problem carefully. Approximate the slope of the leaning side. Well, here's the leaning side right here, Mr. Earhart. I thought this was the leaning side. To be honest with you, both of those will have the same slope. They're parallel. And remember, parallel lines have the same slope. So it really doesn't matter which one you use. I'm going to use this one over here. So I'm going to find the slope of this line right here. This line right here. So how do you find the slope of a line like this? Well, I've taught you guys what to do. Use rise over run. Here's where the line starts. Here's where it ends down here. So we draw a right triangle, remember? This will be the best way to find this is rise over run. In my opinion, there's another way to do it. If you pick up this tower and transpose it onto a coordinate plane and use ordered pairs, I would much rather do it this way, okay? There we go. Now, all I have to do is find my rise right here and my run right here. Well, we know the run already is 16 because it says it's 16 feet off center. Okay, so that means when this point here was originally straight up and down like this, then it was, it was fine. But it's moved 16 feet off center. That means this point here has moved 16 feet off from the center where it used to be. So that's what that means. So your run right here is going to be 16. Now, how do we find the rise? Well, we're going to use Pythagorean's theorem. Is this not a right triangle right here? Sure it is. I've got a right angle right here. And I know the hypotenuse. Remember, the building's 180 feet tall. So the length of this side right here is how much? 180 feet. Now, just because the building tips doesn't mean this line changes. This height of the building here is still 180. Okay, so quickly using Pythagorean's theorem, leg squared plus leg squared equals hypotenuse squared. 16 times 16 would be, and sorry students, I don't have that done, would be 256. 180 squared would be 32,400. Now, subtract 256 from both sides, and you'll get 32,144. And now take the square root of both sides, and you'll get 179.3 if you round it. 179.3. So, the height right here is 179.3, or the rise, I should say. So, we're pretty good now. I have rise over run. Rise over run. So the rise is 179.3. The run is 16. If you type those two numbers into your calculator and divide, you will get 11.2, which is the correct answer. So the slope is 11.2. Okay, moving on to number 42. The Great Pyramid is the largest of the Egyptian pyramids. When it was built, it was 480 feet tall and had a square base with 755 foot sides. Now notice I've thrown a pyramid up here for you to see, okay? The pyramid has two different slopes. The slope of this line here, that's an edge. Okay, does everybody see that? The slope of that line there. Let me use this line over here. It's easier to see. The slope of this edge right here, okay? And then the slope of going from the top of the pyramid down the middle of the side right here. Okay, that's what it says. Look, it says the pyramid has two different slopes. One along its side, this one right here, and one along the edge, this one right here. Which slope is steeper? Alright, no problem. Here we go. Let's get into this, okay? We know it's 481 feet tall, so I'm going to go ahead and drop an imaginary dotted line right down the middle here and have it hit right here in the center. Okay? That's a red line, so I'm going to put 481 in red. Okay? Now, I'm going to put this in green. This length right here, that green is 755 foot, because it says right here, feet. It has a square base with 755 foot sides. So there we go. So we're going to have to find the slope of the edge and the slope of the side both. So here we go. Let's start off finding the slope of the side right here. So I'm going to find this slope right here. Now the best way to do that, like you've learned, is to use rise over run. Got it? So if I connect this point here to this point here, I have a right triangle. Okay? Now, I know the rise already. Remember, this red dotted line is 481. So my rise is 481. Okay? I know my run also. You do, Mr. Arrow? Well, sure you do. I mean, this is the center. So from here to here would be the same as half a length of this. From here to here is the same thing as a half a length of this side over here. Now what's the whole side already? We've already learned the whole side right here, or this side here. Remember, it's a square base. That means all the sides are the same. Has a length of 755, so cut that in half and you'll get 377.5. So the distance from here over to here is 377.5. So I have my run, or my rise, 481. I have my run, 377.5. Type that to my calculator very quickly, and I get 1.27. So let me grab my green pen. So the slope of the side right here, the slope of the side is 1.27. So I'm going to put 1.27 right there with the word sides, okay? 1.27. Now, let's find the slope of the edge, okay? Now, here's the edge right here. I'm going to find the slope of this line here. So I've got my height going down, okay? And my height's going to hit right here, alright? Now, here's my right triangle right here. So if I'm, watch guys, if I'm trying to find this slope right here, then I've got to draw a right triangle to find my rise over run. Now I know my rise. My rise is 481, but I do not know my run. So here's why they were saying you would have to use Pythagorean's theorem, okay? Watch this carefully. So students, I know my rise is 481. I have to find my run. So watch what I do. Draw a line straight down right here. I can do that. Remember guys, look, this is right in the center of the pyramid. So I'm like up top, I drilled a hole and I dropped a chain down right to the center. So I have a nice little right triangle here, and I know this length right here. Now Mr. Arrow, why are you drawing a right triangle? Because guys, I know my rise, but I have to find my run. I don't want to call it X. I don't know that length. So if I don't know the length, I've got to find it somehow. So if I draw a right triangle right here, I know the length of this side right here is 377.5. It's half of a whole side. And I know this right here is also half of a side because it's coming from the center. So I know this side of the triangle right here is also 377.5. So you have a right triangle that looks like this. 377.5, 377.5. Now I'm not going to use Pythagorean's theorem again. You guys are juniors. You've had it in middle school, Algebra 1, geometry, but we're looking for the hypotenuse right here. I'm going to set it up for you. 377.5 legs squared plus legs squared equals hypotenuse squared. If you work that whole thing out, you will get 533.9. So this x right here that my pen is going over right now is 533. 533.9. So your rise is 481. Your run right here is 533.9. If you divide those, you will definitely not get a slope that's as steep as this one here. But we'll go ahead and type it in. 481 divided by 533.9 equals 0.900. So the edge's slope is 0.901, actually 0.901. Okay, so which slope is steeper? Well, the larger number has a steeper slope. So the slope of the side is steeper than the slope of the edge. Okay, and the answer does concur that. Okay, or concur with that. All right, number 43. The percent of female law enforcement officers in the United States rose from 10.9% in 86 to 16.0 in 93. What's the average rate of change in the percent of women in law enforcement? Okay, the rate of change, so in other words, the percentage of change per every year. That's what they're asking for, guys. The percentage of change in these years. So let's see. It rose from 10.9 to 16.0. So the increase was 10.9 minus 16.0. Alright, so we get 0.9 and 3. Alright, or 4 right here.
That's a good lie.
Okay, students, sorry I'm back. I'd like to say that when I make little mistakes like this, please remember that I'm constantly answering questions from my children and stuff like that. Sorry. So, I get things turned around because I'm trying to do 15 things at once. Okay, 16.0 minus 10.9. There we go. And I do know how to subtract. You're going to get 5.1. Okay. Now, that's the change in the percentage. It went from 10.9 to 16.0. So my percentage is 5.1. That's the change. Now that happened in over the course of, let's see, from 1986 to 1993. That's 7 years. So we have a 5.1% change in 7 years. So with my calculator, I'm going to type in 5.1 divided by 7, and I will get, let's see here, 0.72 percentage per year. That's an increase. So 0.72% per year. All right. Okay, students, so, and I think the answer, if I round, it's 0.728. So really, if I round it correctly, it'd be 0.73. I'm not going to be that picky on a test or a quiz, but anyways, so there it is. So your rate of change is 0.73 or 0.72% per year. Okay. All right, moving on to number 44. Let's see what we have here. In 1986, 14.9 of all food servers in the United States were men. By 1994, this percent had risen to 21.4%. What is the average rate of change in the percent of male food servers? Okay, so here we go. We're going from 14.9%, it's basically the same problem all over again, to 21.4%. Okay, so they want us to find the rate of change. So that's going to be percent of change per year. Okay, so we're going from 14.9 to 21.4%. Now, in the years, we're looking at, it went from 1986 to 1994. Alright, so here we go. Now, if I take 21.4 minus 14.9, 6.5. So the difference here is 6.5%. And that change took place over the course of 8 years. So if I take 6.5 and divide that by 8, I'm going to get 0.8125. So I'm going to round to 0.81. 0.81 of a percent. So less than 1%. 0.81% per year. Okay? And there we go, just like that. Okay, students? So that is the correct answer. And there we go. All right, moving on to the next page, or not the next page, but on page number, let's see here, page number 82. So page number 82, number 43. Let me take a second and turn over there myself. And I'll read the problem while I'm turning over there. In the book Fix It Fast, Fix It Right, the following ladder safety features given. Adjust the ladder until it is at least 1/4 of the ladder height from the wall. For example, a 12-foot ladder should be at least 3 feet from the wall. Okay, so which makes sense because listen, what is 1/4 of 12? If your ladder is 12 feet tall, what is 1/4 of 12? 3. You take 12 and divide it by 4. So if you have a 12-foot ladder, you want it to be at least 3 feet from the wall, at least. What is the maximum slope that this book is recommending for a ladder? And then, of course, why do you think it's unsafe to set the ladder up too steep? In other words, here's the house you're working on, and instead of setting the ladder up like this, you're not very intelligent, and you set it up like, you put the base right here, and you set it up like that. Was a good chance you're going to fall backwards. So we know the answer to that right away. Okay, so the main answer we're trying to solve is what is the maximum slope that this book is recommending for a ladder? So here we go. We can draw our own diagram and use our own numbers, or we can just use the one they've given to us. Okay, so here's the ground. Here's a house, and of course it's not a very straight house. That's a little better. And here's my ladder right here. Now remember, we're going to use their features. Listen guys, you could have used a 16-foot ladder as long as you put this, call this a 4 right here, okay? As long as you're consistent with your 1/4, okay? So they're telling us the ladder itself from here to here is 12 feet. So we're going to put it 3 feet away from the wall. Now we have a right angle. We're trying to find the slope of this line, right? How do you find the slope of a line? You've got to find rise over run. Well, I know the run already. The run is 3. Just find the rise. Guys, once again, Pythagorean's theorem. Leg squared plus leg squared equals hypotenuse squared. You're going to end up with leg squared equals 144 minus 9, so 135. And then take the square root of both sides. The square root of 135 is, let me grab my calculator real quick, guys. The square root of 135 is 11.62. So now I know this height right here is 11.62. So my rise is 11.62. My run is 3. So 11.62 divided by 3 is going to give me the slope, which should be, let me check the answer right here. I'm getting 3.87. So I'm going to round that to 3.9. And the answer is 3.9. Okay, so we found the slope of the ladder by setting up a picture and using rise over run. Okay, not too difficult. Alright, moving on to our last problem. I think, is that our last one or not? Let's see. No, we're going through 46. Alright, number 44, here we go. This is pretty easy here now. This might be the easiest one we've done on this assignment. The members of the marching band are selling pizzas and submarines. Their goal is to make $1,000 profit. They're going to receive $2.75 profit for every pizza. So pizza, they're making a $2.75 profit. For every sub, they make $1.50 profit. So every sub is $1.50. Write a model that shows the different numbers of pizzas and subs the band members need to sell to achieve their goal. $1,000. Well, guys, that's easy. You take 275 times every pizza that's sold, plus you take $1.50 times every sub that's sold. I'll put a line here so you won't think it's a 5. And that has to equal how much? And we're done. That's a model. We're finished. So 275 times every pizza, that gives you all the profit for the pizzas. $1.50 times the subs, that gives you all the profit for the subs. Add those two together, and it should equal $1,000, or more would be fine. So there's your model. Okay. All right. Moving on to number 45. Same thing. Exact same problem. Student tickets at your high school football game cost $2 each. Non-student ticket tickets cost $5 each. Your total gate sales was $6,800 for your tickets. Write a model that shows the different numbers of students and adults who could have attended the game. Okay, no problem. So we have student tickets. We're going to multiply that by $2 each. Plus, I'm going to use the letter N for non-student tickets. Non-student tickets get multiplied by 5. So every student ticket gets multiplied by 2. Every non-student ticket gets multiplied by 5. Add those two together, and it's going to equal $6,800. So this would be the model, students. That gives you, it doesn't tell you the exact amount of students or non-students that came, but you can actually put in a number for S. Like if you know 200 students went to the game, you can put 200 in for S right here. And then find out how many non-students came by solving for N. This is a really good model that models that situation. And there it is. Okay. Alright, moving on. Number 46, last problem. A recommended maximum slope for a wheelchair ramp is 1/10. What does this mean? Well, it simply means, here's your ramp right here. It means every time you go 10 feet, we'll say 10 feet, it could be inches, yards, whatever. 10 is your run, 1 is your rise. So it means every time you go over 10 feet, you have to go up 1 foot. And if you go over 10 feet, go up a foot. 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 So when it says, what does this mean? It just simply means for every 10 feet that you run, you have to go up 1 foot, or for every foot that you go up, you must go 10 feet horizontally. Okay. Now, if a business was to install a wheelchair ramp that rose 16 inches, the height of 2 steps, what would be the minimum horizontal length of the ramp? Okay. So how long would the ramp have to be? Now think about this for a second, okay? Let's set this up. We start off with our original slope. Now think about this. Your rise over run. Now, listen, you want, your business wants to install a wheelchair ramp that rises 16 inches. I'm not worried about the inches right now, just 16. So your slope is rise over run for every 1 foot or inch, whatever, we'll call it inches. For every 1 inch you rise, you must run 10 inches. Well, you're going to rise how many inches? 16. So think about this. If you took the 1 and multiplied it by 16 to get 16, take the 10 and also multiply it by 16, you get 160. That should make sense. Think about it, guys. For every 1 inch you rise, you must run 10. Well, you don't have 1 inch, you have 16. So you've got to multiply 16 times 10 to give you 160. So for every 1 inch you rise, you run 10. So for every 16 inches you rise, you must run 160. Okay? And that's what it's asking for. What would be the minimum horizontal length of the ramp? Now listen, when you hear length of the ramp, you're thinking of this diagonal line right here. It's not what it's says. It says, what is the minimum horizontal length? So if you're rising right here 16 inches, then the horizontal length right here must be 160 inches. Now the problem is that doesn't match the answer, but it actually does. Their answer is at 10 feet, 13 inches. So if you have 160 inches, sorry, they have the answer. Their answer is 13 feet 4 inches. Okay, so convert this to feet and you'll be fine. Take 160 divided by 12, and you get 43. You get 13 with the remainder of 4. So in other words, 13 feet 4 inches left over. So I really don't care if you wrote your answer as 160 inches. That's fine, or 13 feet and 4 inches. But that would be the correct answer. They're the exact same thing. Okay, I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.